Hi there. Let's look at probability and statistics review questions 1 to 7. So, do you believe that being male or female? So, does gender have an effect on how prepared you are for class? Here's how we're going to look at these data. So, we're going to classify our subjects, our total of 30 students, as to their gender, and as to whether or not they have an A or B homework average, or a C or lower homework average. So to start filling in the table, I've got 30 students total. Of 18 students that have an A or B homework average, so that would be the total of the A or B row, I know that 6 of them are male. So 18 take away 6 leaves me with 12 for female, and the total of 30 take away 18 leaves me with 12 students total that have a C or lower on their homework. Now, we're not able to fill in the shaded part of the table yet. We don't have enough information. And that's because I'm going to ask you to rig the question. So, in other words, some students asked me today what it would look like if we actually had 2 events that were independent, and we are going to force the data to have independence. Take a look. If one student is randomly chosen from this class, find the probability that they have an A or a B on homework. Well, the total of that row is 18 out of 30. So the event, A or B homework average, 18 out of 30 is that probability. Now, if the events being male and the event A or B on homework, if those are independent, then based on this answer from number 2, I know no matter what condition I put on A or B, so for instance, A or B on homework, given that the subject is a male, this condition should not affect the probability of A or B on homework if in fact the event A or B on homework and male, if those are independent. So this probability should be the same. This is what must be true. If this probability is 18 out of 30, then the conditional probability conditioned on male must also be 18 out of 30 in order for the 2 events, male and A or B on homework, in order for them to be independent. Now, another way of looking at this same conditional event in question number 4, from the table, I know that the probability of A or B on homework, given that my subject is male, so the condition means I am looking only at the male column. I don't know the total number in the male column, but I know to set up this conditional probability, I would have to take the 6, those are the ones that have an A or B on homework, over the total of the male column. So what's so special here, though, is now we can figure out what's going to be required for independence. So this conditional probability in number 3 is the same as the conditional probability in number 4. So what that means is this 18 over 30 has to be exactly the same as this 6 over the total number of males. So just to keep the cross-multiplying a little simpler, I replaced the total of the male column with question marks, so I'm just going to do that same thing here. So if I solve this, I'll know what the male total needs to be in order for the 2 events to be independent. So 18 times the question mark, that's going to equal 30 times 6, that's 180. So if I divide by 18, that male total that I'm missing has to be 10. So now you can do question number 5. Now you can go back and complete the table from number 1 using this total. So now you'll be able to find the other values. Using those other dark shaded values then, you can answer question number 6. So you'll be able to find this AND probability. You'll be able to calculate this OR probability. And then you'll also be able to calculate this conditional probability. Now, if you look very carefully then at question number 6, in order to answer question number 7, you're going to want to compare this probability with the probability in number 2. Think about looking those as decimals.